14, question 1. The graph shown has equation y equals x cubed minus 6x squared plus 4x plus 1. The total shaded area is bounded by the curve, the x-axis and the y-axis, and the line x equals 2. Calculate the shaded area labelled S, hence find the total shaded area. Well, here's the shaded area for S, so we can see clearly that the upper limit is 1 and the lower limit is 0. So between 1 and 0 we're integrating the function x cubed minus 6x squared plus 4x plus 1. So remember, a basic rule for integration is you add 1 onto the power and divide by your new power. Remember, if you integrate a constant, it becomes a constant x. So x cubed becomes x to the 4 over 4. 6x squared becomes 6x cubed over 3. 4x will become 4x squared over 2. And integrate 1 and you'll get 1x. Now, before I make my substitutions of 1 and 0, I'm just going to tidy up what's inside the rectangular bracket. So that's x to the 4 over 4 minus 2x cubed plus 2x squared plus x between 1 and 0. I'll now make my substitutions. So that's 1 to the power 4 over 4 minus 2 lots of 1 cubed plus 2 lots of 1 squared plus 1 minus, open up, 0 power 4 over 4 minus 2 lots of 0 cubed plus 2 lots of 0 squared plus 0, close the bracket. 1 to the power 4 is 1, so that's just 1 quarter, minus 2 times 1 cubed is 2, plus 2 times 1 squared is plus 2, and plus 1. This stuff in the second bracket collapses down to 0. Minus 2 and plus 2 cancel out, so I've got 1 quarter plus 1, so that's a quarter plus 4 quarters, and that's 5 quarters, and that is the shaded area for S. I'm now going to find the shaded area down here below the x-axis. Now what I should find is that I get a negative result here, but I'll ignore that negative result and add my result to 5 quarters to get the final answer for the total shaded area. So we can see this time the upper limit is 2 and the lower limit is 1. So it's the exact same function we're looking at. So we've already done the hard work in terms of the integrating and tidying that up. So now it's just a case of integrating between 2 and 1. So we've integrated and make substitution. So that's going to be 2 to the power 4 over 4 minus 2 lots of 2 cubed plus 2 lots of 2 squared plus 2, close the bracket, minus, open up. 1 to the power 4 over 4 minus 2 lots of 1 cubed plus 2 lots of 1 squared plus 1, close the bracket. Two to the power 4 is 16, 16 over 4 is 4. I then get 2 cubed, which is 8 times 2 is 16, so that's minus 16, plus 2 squared is 4 times 2 is 8, plus 2, minus, open up, and in here I've already worked out earlier on that if I sub in 1 I'll get 5 quarters in here, so I can just use that result and speed up the process a wee bit. So in here I've got 4 minus 16, which is minus 12. Minus 12 plus 8 is minus 4. Minus 4 plus 2 is minus 2. So I've got minus 2 minus 5 quarters. So minus 2 is going to be minus 8 quarters, minus 5 quarters is equal to minus 13 quarters. So that area then can be given by (13/4) square units. So again, I'm ignoring the negative. I expected to get a negative result there, but ignore it because that's the peculiarity of getting the area below the x-axis. The total area then is given by 13 quarters plus 5 quarters, and that's 18 quarters. Make sure you simplify that down. That's 9/2 square units, and that's fine.